India has been excellent in the area of cybersecurity, especially on many of the analytical work that we can think about it. Okay. Okay, if it's a little difficult, then we can move on. Okay. Yeah. Okay, go to the next slide. Yeah, please.
Next, please.
Okay, so go to the next slide. I think so.
John, next.
Go to the next slide. So there are many research organizations that I'm involved pretty much in India. Like if you look at it, I work with every IITs that you can think of. I work with IIT Kharagpur and the Indian Institute of Statistical Institute, Indian Institute of Science. That's where I came from. So there's a lot of these kind of things. Okay, go to the next slide. So there is two things that is very important nowadays. That's the whole focus of this talk is, the three-dimensional aspects of deep learning. The design, development, and deployment. That's very important for every type of applications that we can think of. So I've given a copy of the book to Dr. Subramaniam. So please try to see, very interestingly, what we have done is we have been able to give a code for every application. And I think that should be very useful for especially students or even researchers and things like that. So that should be able to happen. Okay, go to the next slide. Okay, so the interesting part of it here in 2010, Dr. Abdul Kalam was visiting United States, Rice University, to have a joint kind of program from our university, Rice University, and that's where you see this is almost about 14 years back, 2010. And so one of the things I was able to understand with President Abdul Kalam was a very visionary. So he gave a talk, and then we had an agreement sitting there. And then one of the things he brought me to the side and said, Dr. Iyengar, what is very important nowadays that we think is the security of information that we have. How secure is the information? Can anybody sort of, tap into the information we have? And so is it possible that we focus on this area of secure information is very critical for any organization, okay? Now, this is what I call as a visionary by Dr. Abdul Kalam. And then, so later on now I see, because of all of those things, which at least, he was talking to me, I'm sure he has been able to convince the appropriate people in India to develop an institution like SETS, which is very important. So you can see the enormous progress of this particular organization that you're all with. So coming back to this information security, he was able to even think about in those days. 14 years is a long time. So that's why I think we are very grateful to, a scientist like Dr. Abdul Kalam, in addition to all the things, whatever he has done. Not working? Okay, wait, yeah. Okay, so the purpose of my talk is to develop solutions to predict attacks, okay? And on digital footprints, whatever that, yeah, you can give me that, I can just, because I can move around here. So to actually identify the footprints, and what is interesting is not after the attack, while the attack is going on, and after the attack also. That's very important, because especially nowadays, prediction of these attacks can be very catastrophic. I can give you several instances in the United States. One instance I can give you is some of the Russian folks several years back, they were able to get into the instrumentation of the oil flow from all the way from Maine all the way to Florida. So they were able to sort of attack the flow of oil and from almost the entire East Coast. Now, the importance of this is for several days, there was no petrol, no gas for any cars to move. And that has cost a lot amount of money. And some of the oil companies, they were not kind of very careful in seeing that it is going to come. So just to give you the real problem of these attacks that can take place. So nowadays, if you can look at it, our data comes from different places. Okay, social media both. That could be very dangerous. I mean, some of them good, some of them are not good. So then news item, that also the information that comes. Then what kind of cues that we can generate based on all of these data? That's very, very important. Okay. So in our research, we also kind of model anomalous activities. Okay. Planning and coordination of both digital as well as physical events. That's very important. So if you look at it, when you're sort of looking at it, we want to look at some of the keywords that we can explore. Very, very important, in communication and even on the social media book, because those kind of keywords can certainly give a structure to the footprint of why the attack is taking place. Okay? Now, our threat prediction algorithm is based on public data. We can use it. Then it can also use both public data as well as the private data. Data is very important. As I said, it is like think story. While you're telling a story, what is that it is important that I can understand based on that? So what we have been able to do is we were able to use what we call as an explainable AI techniques to model and sort of see what kind of insights that we can use in our prediction models. There's a lot of good mathematics also in this framework. Okay. So one of the things I think is a very important point is in our technology or the method, we try to remove bias, okay, or an imbalance in data sets. You understand what I'm talking? No, bias can play a very significant role. Just to give you an idea, there's a lot of bias, in data. If suppose if the crime is committed by some groups of people, for some reason or the other, who do not have a favorable opinion among the community, it can bias the whole thing. It can happen, like African Americans, Hispanics, or any other group. So we must be able to see the data that we have and how we can sort of remove these kind of bias. And then also in many of these applications, when you have the data sets, the authenticity of the data set is very important. So that's where we are worried about all of these communication and so on and so forth. Now, here is a good example that I want to tell you and focus on everybody. So did you hear about a programmer and a web controller who actually avoided a major cyber attack? It's a real thing happened. So if you go to New York Times, April 4th, 2024 article, a Microsoft programmer who was sitting there was able to look at how the attack is taking place on time. Okay? And what he did was, he was a very good programmer and he could notice some changes and which is kind of oscillating in the entire program. And then what he did was he could immediately recognize, oh yeah, there is some attack that is taking place. So what he did was, as soon as he noticed a small change in the code, which is kind of reminiscent of building up and collapsing the entire network, immediately he sort of used a kind of a powerful predictive models to minimize it and cancel it. So this is the real thing that happened. If the attack, if it had taken place, it would have costed billions of dollars. So what he did was, I mean, every time this is what we call as monitoring the system. And a good monitoring system can see when the attack takes place and how he could minimize that and how he can write a code to diffuse the whole thing. So that's a very important aspect of a research or a model that we are interested in, analyzing the attack as it is happening, and then maybe after the attack also we'll be able to analyze so that we can prevent these things would not happen again. Okay, so this is the motivation. So data-driven cybersecurity has kind of revolutionized the threat prediction. Okay, so now one of the things that we are using is the tools from AI and machine learning. Now, these tools are very important because remember, when we have all of these data, which is coming from different places, how do you sort of converge to a place where I can look at the data and then come up with some sort of a methodology or a model to understand? Because some of these data sources that is coming from different places that can elevate the threat and make it complex in the context of analysis. So we have several important algorithms and methodologies for predicting, these kind of threat analysis. The applications are enormous for Army, Navy, and even the banking transactions, the finance. If there are two countries they are in a war, like for example, Russia and Ukraine, they had to be able to predict, what kind of threats they can anticipate, and then strategically they'll be able to sort of move from one place to the other. So this is a very critical and important area, in my opinion. So how do we do? What do we do for navigating this kind of the ever-evolving landscape of cyber threats? I mean, this is not something that's going to happen today and not going to happen tomorrow, because this is a kind of a landscape that is developing very fast. And one of the things which we have noticed is these are dynamic threats, okay? And these are very challenging. I mean, these are what are called as every moment in time, there are threats which are changing. So that is why it is called dynamically changing threat on a system. Now, complexity of cyber attacks is also very important because it kind of evolves around different tactics, techniques, and procedures. So you can't simply say, I have a method that I'm going to use it, because these are very different types. So how do you sort of come up with a procedural, an algorithmic solution, or an implementation procedure, or any of these kind of things that you can use to minimize and to detect, to challenge and to detect also. So what are the problems of the traditional approaches? Okay, so there are lots of methods we have, for kind of measuring some of the cybersecurity things, but they pretty much rely on static rules, okay, and signatures. They're not good because, as I said, these are dynamic threats. Every moment in time, these threats are changing. So the limitation of many of these cyber, approaches that we have, they're very static. They're not dynamic. So they cannot provide adequate and novel methodologies for minimizing the threat. So you understand basically the kind of problems that we have. Okay, so now what we are interested in years to come is to come up with, through the stakeholders who are involved in any of these things, is to come up with what is the global standardization or global collaboration that we can do. So I want to go back again to Dr. Abdul Kalam. This is what he was talking about, secure information sharing. Okay. So what kind of framework that you have to exchange information from one party to the other among all the stakeholders? I mean, these are very important, whether it is for banks or for any type of transactions, or maybe two submarines underwater, if they are trying to communicate one with the other, we need to be able to see how best we can do and safely, communicate and secure the information. So then you need to be worrying about implementing platforms for secured shared information. I mean, we have different types of, collaboration, everybody has something different, but not a very standardized one that we can use that as a platform for minimizing any of the risks that we have whenever that we are trying to do the information share. So this is where the interesting idea of what we call as threat intelligence integration. I saw one of the slides presented by Dr. Subramanian Stevie's threat intelligence management. Very important because integrating all of the threat intelligence platforms and how do you start to kind of automate the flow of actionable items between the entities. That's very important because how do you sort of, take some good things from one place and use it and make it secure? Then applications are different. I may be talking about underwater applications. I may be talking on a banking transaction. So there is what is called as interoperability. So that means there are standards and protocols for ensuring the interoperability between different threat intelligence and feeds and platforms. You see the point? That's very, very important because see, when we look at any of these platforms, we have a secure communication protocol underwater between the two submarines. That's good, but can I use some of the same ideas, even on the surface, or maybe for a different application? So the interoperability is something very, very important. Now, when you look into this, there are two different levels. One is called the low level and high level strategic things. So the high level information is very, very important, and that keeps changing from one task to the other. So the person who is kind of tactical, who is an attacker, okay? What kind of methodologies that he has used, what techniques are the procedures. So we need to be able to see at a tactical point of view. Now on the technical aspects, what kind of indicators that we have on a very specific malware. That's very important because you know that we are using IoT devices, millions of devices that we use. So any kind of malfunctioning on any one of them can result in the overall collapse of the internet or any type of application. So the idea is what we call as the incident response system. So this is very, very important. Now, in terms of the operational process, we are also interested in a very specific incoming task on any type of threats, okay? And so if it is kind of a defense-oriented thing, what is that we can do in the context of this? Now, as I said, the social media platform are very important. Here is an important kind of attack events that takes place, or it is still going on. So what kind of techniques that we want to use for retrieving data and do the analysis? So here is an example. The national school system was an anti-Christian hate crime by a radical Democrat transgender activist. So you can, get all of the keywords. So that is the tweet. Somebody sent it at 7:40 a.m. p.m. Then related attack event. There are 3 children and 3 adults have been killed. So I'm just showing you some examples of what happens on many of these attacks based on the Twitter. On another example of the main shooting in a different state, so you can see correspondingly the police were alerted to wield threats by US Army reservists. So then you have the attack, 18 people killed. So similarly with all of these examples, this is what we call as we take this data we create a story out of this data to see, for example, what are the events that has taken place and how that can be used for minimizing it. So what is the goal? So the goal is to find a foundational framework of threat analysis, and it has to be grounded in science. I mean, I can't just use one method and say that, it can be used. It has to be very generalized, and sound principles of machine learning should be used. And you remember when we talk about any of these kind of attacks, you're talking about large amount of data items. I mean, the billions of data items that you have. So the question is, how do you sort of take these data, electronic data, available through sensors and related data, and how do you sort it, and how do you create important, inferences from that? So what is that very important is what we call as how does it provide value added contextual information. Context is very important so that we can better understand and comprehend to some of these trending things. You understand? So the context and the contextual information for all of these things are very critical. So just to give you a little bit of a framework for defining the strategies for anticipating and identifying anomalies in cybersecurity. Okay, so in a hypothesis, we basically say anomalous activities, including the planning and coordination of digital and physical cyber attacks, that can lead to a search, in a specific keywords across communication channels, social media platforms, and news outlets. These are very important. I mean, as I said in the beginning, we are interested in coming up and identifying some of those keywords. So when we do that, there is an information queue and the keywords queue that is left behind all of these attacks. All of these attacks. So that's where we have a person who is analyzing these attacks ongoing and is able to sort of identify them. Then the methodology is what are the machine learning methods for anomaly detection? I'll show you that in a minute. Then our team at FIU and Syracuse, we have proposed some of the foundational advancement in prediction algorithms. We have been very successful for identifying the potential threats and also doing the forensic analysis for post-attack investigation. Now, what is the uniqueness behind all of those things is we've been able to use some of the state-of-the-art machine learning techniques, such as transfer learning, okay? A few shot learning, one shot learning, and hidden Markov models. These are 4 important techniques nobody has been able to use as on today. Then, by using many of these techniques, we've been able to uncover some of the underlying patterns and correlations within the data streams. Source, diverse channels, newspaper articles, and social media posts. So what is that I'm trying to tell you is there is what is called as mystery of relationship that exists among these data items. And that's what we kind of uncover and discover those mystery connections that you cannot see, in a normal approach. So this is where we are trying to use in our algorithmic structure. So this is our framework. This is the first framework that is available. No other framework which is kind of available as on today. So this is the first one we proposed on April 24th. So you look into the social media. So there are 3 different phases. Okay, as I said, news outlet, text messages, emails, phone usage data. This is all the data that we normally use or collect for the analysis of the attacks, right? But this is collected even while the attack is going on. So there are 3 important phases here. One is called the phase 1. Well, in the phase 1, we essentially extract the features from the post or messages, whatever that we have, some of the keyword extraction, bag of words. Okay, here are some examples. Then feature extraction from sensor data, location features also. So I'll come into the little bit of details on the mathematics and the learning aspect of it in a minute. So phase two, the machine learning aspect of it. So once we have these data from the feature analysis, we sort of run through the intentional, then we look into the emotional analysis, then we create a threat profile, then we have a pre-attack prediction, then we give a threat prediction. An example is individual X may use a gun to attack somewhere in Chicago tomorrow. So we collect all of these data and then we relate this data, identify the identification, and then we do a forensic analysis. So that's the machine learning part of it is for health for the second component of it. Phase three is the interpretation. That's very, very important. So how do you sort of enhance user confidence and trust, explain predictions, identify the errors? As I said, the bias can play a very significant role. And then you kind of put a post-attack identification analysis. So this is a kind of a beautiful framework that we have in the context of analyzing the attack that is going on and even after the attack. Okay, so now let's look into some of the mathematics of it. So enhancing the reliability of transfer learning through what we call as a few shot or single shot learning. So what is the innovation and methodology that we have? Now, our method, what we have explored is what we call as a domain-specific nature or feature extraction to make sure the model focuses on capturing, data related to gait, swiping, typing, and phone usage behaviors. Very important. Nobody has done this. Okay. Now, the second aspect of it, concentrating on specific keywords, interactive hostile intent like attack, gun, hate, time, location. Okay. So the third component is the social media part of it, aims for intention and threat analysis beyond certain general sentiment analysis we provide. So the strategic feature extraction and selection enhances the model reliability in face of limited training data because we may not have a large amount of training data. So this is what the most interesting aspect of it. Now, then we use what we call as ensemble models. So what we do is sometimes there is always a problem of or the scarcity of having simultaneously social media posts, behavioral metrics data from individuals during the attack. So we do what we call as we pre-train models on data sets for each distinct modality. So all of these things are a program that we have on the system which does that. So these models are subsequently combined into an ensemble model, weighted model, and fine-tuned with sparse actual data available. So what we are trying to do, we are able to sort of get the analysis part of it, even in spite of the data which may not be available in plenty, but there are models and predictions that we have been useful. So let's give some mathematics into the innovation. So the foundational science, if there are so many variables for intention analysis, emotion analysis, model everything, then we sort of give the weight set represents for each individual model. And then we define what we call as a loss function L, which is a kind of measures the distance between the model's output and the target. Then our objective function is basically to optimize the ensemble model F and our weight alpha to minimize the loss. So this is the mathematical structure that is being used. Okay. So the next thing we said is how do you sort of do in the phase one, enhancing the reliability of transfer learning through diffusion. So our method is very unique and novel. it uses what we call as an adaptive meta-learning algorithm. So which can dynamically adjust the learning rates of both learner and meta-learner. So that's a very beautiful thing. I mean, I said in the beginning the traditional approaches is not helping because they're very static. But whereas our model here, the adaptive meta-learning algorithm, it does what we call a dynamical adjustment to the learning rates of both the learner and the meta-learner. So that's very, very important. So therefore, the interesting implication of this is the model's adaptability and potential for generalization across diverse tasks. So here is the mathematics we have, where sigma 1 and sigma 2 shows how to calculate the learning rate for the learner as well as the meta learner. So there is a very beautiful science behind all of those things. So equation 1 essentially gives you the rate of learner is a function of the current parameter, the current gradient, the current loss, and the previous learning rate. So that takes into account all of the kind of things that we are talking. So equation 2 basically capitalizes on the meta learning, on the function of the current parameter value, and the current gradient, and the current loss. So these two equations essentially encapsulate the idea of the dynamic adaptive learning rate, with the learner able to quickly learn sufficient information while the meta learner has control over the learning rate to avoid any divergence. So this is a very beautiful mathematics. This is the first. You don't see that anybody has done using the AI and machine learning model. Now, examples of data collection. So here, I mean, this is something we implemented, task performed, benign activity like transcription, browsing, and note, some of these operating system windows, average keystroke per user. So we have all these data. I mean, if there is a hacking from somebody, and I will be able to profile that particular person where he is to measure the key, how he types, what is the keystrokes. We have that type of a model that we can use. Demographics, where's the gender, male, everything we'll be able to characterize. And the span of data collections, we did that for 3 months. And this is the public data sets anybody can use. Okay, that's phase 1. So that is the phase 1. Essentially, we talks about the feature extraction. Now, the second phase, what we call as an uncertainty-aware transfer learning. Now, ours is a very unique approach. We embed uncertainty estimation within the training phase. That's very important. Okay, and that's termed as uncertainty-aware transfer learning. This we do that to improve the reliability of transferring learning in our tasks. So you see the mathematics and the underlying principles of machine learning. So our method involves varying rates of certain layers, such as the dropout layer during training to generate multiple outputs for the same input set. Very important. So in our convolution neural network model, our method essentially involves varying rates of certain layers. So there, by using this, we are able to estimate the output distribution, calculating the model's uncertainty, and incorporating this uncertainty directly into the training loss function. So beautifully, this explains, how any uncertainty that we have during the learning process can be explained. So what are the methodologies? So we consider a neural network comprising of k layers, each with a weight and a conventional loss function M, comparing the model's predicted output with the strategy. Then with n trained samples, each of them represented with employing L2 regularization weighted coefficient, we can define a general loss function in the following form. You see that on screen. So therefore, the distribution of output can be approximated, and where small w represents the weight matrix, x star y star represents the standard input output. So this is a beautiful methodology that we can envision for this. Then by doing some more sampling and doing all of these mathematics that you can see, we can integrate, that's what the whole idea is, of how uncertainty into the loss of calculation with a penalty for high prediction value. So this is an uncertainty aware transfer learning. So that's the second thing. So that means we have been able to do the feature extraction, that we've been able to do the uncertainty in the data. Then phase 3, we have an independently identified novel phenomenon. That's also we need, because as I said, our methods develop an anomaly detection module as an assistant to the whole model. That's very, very important, because this module aims to facilitate the identification of outliers. See, a lot of these kind of things within the vast data sets of unlabeled social media content, the outliers are very important. So leveraging an unsupervised learning from pattern discovery and incorporating a real-time processing capabilities is something very, very critical to the success of the entire model. So this model is kind of identifying a novel phenomena that takes place independently. So what is the uniqueness of our system is able to generate an integrated and analyzed patterns across varied data types, domains, accounting for potential inter-domain relationships. That's very important in analyzing all of these data. Okay, so the machine learning techniques for anomaly detection is we use what we call as a transfer learning. So what we do here, adoption of all the pre-trained models to cybersecurity tasks, enabling the extraction of all of the meaningful features from diverse data sources. Then we use the few-shot and one-shot learning. These are the techniques for limited label data. And then we use finally the hidden Markov models, which is essentially a statistical model for modeling the temporal sequences of observation, okay? Aiding the detection of anomalies and also by identifying the deviation from expected patterns. So there are a lot of deviation that may take place from the expected patterns in sequential data, as well as the communication log. So all of these three important aspects of it can actually unify the characteristics of the model. So now, integration of diverse data streams for threat analysis. So you have data sources, incorporating data from various sources, all the things like blogs, newspaper items, and so on, to essentially get an understanding of a view of potential threats and what are the anomalous activities. Then the interesting thing in the integration is we do what we call as cross-stream correlation. So what we do is by applying some of the advanced machine learning techniques, we can explore and discover correlations and patterns across diverse data streams. So therefore, this happens and enables the identification of the coordinated task and minimizes any threat errors that we might encounter. So finally, the forensic analysis is all of the insights that is being gained from the machine learning to conduct a forensic analysis of the post after it is done. So the attribution of any of the malicious activities and information of the future threat mitigation strategy. So this is the integration of different data spectrums or the streams of a given threat analysis. So the technical approach for the forensics aftermath of the task. So you want to somewhat find a detailed documentation of the cause, reasons, and culprits. Then during the forensic analysis, we will find out what happened, where, what, and when. Then the focus here is going to be a decision or a prediction of the analysis of all the text and social media to see if there was any evidence that is available. So most important thing is there are variables that are not known, but it can show up in the post prediction algorithms. So part B now. So to give you an idea on the AI and machine learning in infrastructure security, anomaly detection is machine learning algorithms. So we used unsupervised learning techniques such as isolation of forest, one class SVM techniques. And how do you implement it? You implement it by anomaly detection algorithms into the network, then system monitoring into infrastructure for real-time threat analysis. Okay. Now, on the predictive analytics, we can model through AI techniques, incorporate algorithms with random forest and LSTM for forecasting potential threats. And the application of this is leveraging the predictive analytics to identify and proactively defense measure. Now, AI and machine learning in the adaptive response mechanism is very important. This is what I'm going to stress now is our AI-driven approach, adaptive response mechanism takes into account dynamic threats that are happening and changes every minute, and automated incident responses, what can be done. So the integration part of it is adaptive responding system with security orchestrated pattern platforms for seamless kind of incident resolution. So this is the most important system, which is very unique with our method. Nobody has done this. You can go and do a literature survey because dynamic threat modeling and automated incident responses have not been explored using AI and machine learning. So we were the first people to sort of use that. So we have also sort of studied under different case systems. One is a physical sabotage at a manufacturing facility. We took some data, a large manufacturing facility, which has a lot of critical components for various industry. Like, for example, semiconductor industry. You have a machine. You have a component where it is kind of manufacturing a lot of semiconductors. No. So in this place, a disgruntled employee with advanced knowledge of the facility operation, he can sabotage the production line. So this is where I see how, for example, this can be avoided in future. So the whole idea is one example which costs billions of dollars for a semiconductor industries can be avoided with some of our methods what we incorporate. So the technical analysis of the AI algorithms, and which are what are called as rapid threat identification is important. That means real-time analysis and identification of the threat. And then you have to sort of integration with the physical security. So what we do is a detailed examination of the integration process with the AI, such as surveillance camera and access controls and some of those examples. And then, of course, sometimes we will also use the previous experience, like extracting technical insights from the case study to enhance for the future defense strategy. So it's a kind of a cyclic process. We do the incident response system, we actually cover it, and then we use with integration. And sometimes if it is not successful 100%, then we learn from the mistakes of what had happened, and then we are able to sort of move on. So the other example that we tested is integrated early warning systems. These are very important. Alert about potential disasters like tsunami. I think it can be done fairly nicely now. Incorporating one of the most important thing is the real-time data from sensors, satellites, and weather station. This is what I did when I was at IG Car, because Dr. Baldev Raj was the director. He was telling me, in case if there is a serious radiation leak, Dr. Raj, can you define a system? So we were able to do that and provide them to the Department of Atomic Energy. I think not very sure who was there, but we provided a report in the form of research papers with the collaborator like M. Krishna Kumar and others. What we did is we took all this information, we came up with a model and gave a proposal in such a way how to minimize these kind of incident response systems or early warning systems. So implementing an automated alert systems with multiple communication channel is also going to be very important. Now, the other interesting aspect of it is geographic information for risk mapping. Role of GIS is very important in visualizing and analyzing spatial data. That's what I was talking to the director here. Automated visualization system and the virtual framework. So how do you sort of create a risk map for effective decision mapping? Because the threat is taking place and you're able to see visually what kind of decisions that you can make using AI. So integrating the GIS with real-time data for dynamic risk assessment is also very important. And then, of course, the next study foremost, the number 3, drones and remote sensing. Applications, utilizing drones and remote sensing for rapid damage assessment. The best practices is how efficient your drone is, how good and decisions that it can make using AI and machine learning for aerial surveys in disaster-stricken areas. So integrating all the remote sensing data from accurate damage estimation is what is very important in many of these drones. And so we've been able to do that for many of the hurricanes. That in Florida, we get a lot of hurricanes. So we've been able to deploy drones to predict, if the hurricane is going to land in few minutes. So we are able to do that because it can get a lot of those, and then it can save lives. And the decision ability is, the insurance company, they are very much interested in getting early decisions to tell people to. So we've been able to use drones and forensic analysis for hurricane. This is one of the famous work we did in Florida, what we call a hurricane loss model. Because whenever there is a hurricane, billions of dollars, the whole thing gets, I'm sure, you're also in a similar situation. So we've been able to use some of these applications. Now, artificial intelligence and predictive analysis is very important. And what we want to do is to kind of use efficient machine learning algorithm to analyze historical data. See, a lot of times there are some good reasonings that you can bring out and do it by looking at some of the data that already exists, like predicting earthquake. That's being used very much because they look at the earthquake data and then see is there a potential possibility of getting an earthquake this year or next year. So they have this historical data and using the machine learning algorithms, so implementing AI-driven models for predicting disaster impacts are very, very important in many of these applications. Now, the next and the most important thing to me is cloud computing for data storage and accessibility. Very important because cloud computing in disaster data management is very beautiful. And how do you sort of use is, how can you use a good cloud platform for ensuring what we call a scalable data storage. Scalability is very important. So ensuring the data accessibility for multiple stakeholders for in real time is what is very important in many of these applications. So ongoing threats and emerging technologies, there is what is called as advanced persistent threats. The sophistication of advanced persistent threats, their tactics, their techniques and procedures are very different. So you need to do a continuous monitoring. Emphasizing the need for continuous monitoring is very important for this. So threat hunting to detect and mitigate APTs in real time. This is a very fundamental problem is how do you sort of use this to detect, hunt for it, some of these advanced persistent threats in real time. So these are some of the important applications. So ongoing threat and emerging technologies, quantum key distribution. This is a very famous, a lot of work has been done here. How do you sort of secure a good communication model? That's very important in quantum key distribution. And then mitigating quantum threats, okay? Addressing the potential risk that is kind of proposed by quantum computing to traditional encryption methods. So we have a paper that is being published, which is going to come, is quantum encryption, which is being used for many of the real-time applications. So in conclusion, there are three important, messages that we can take home. One is AI-powered advancements in cybersecurity, physical defense, very important, and emphasizing the ongoing research and development and collaboration with cyber physical security domain. Remember that. That's also very important. Then, of course, the journey continues towards a resilient future for our critical infrastructure. So these are the kind of things. So what I've done basically is to sort of give you a kind of a framework. Now, this has not been done anywhere. So the three different methods of AI and machine learning that we have, a proposal submitted for $1 million to National Science Foundation. And I think because the uniqueness is we are coming up with new innovation, new techniques, then we translate that into technology. See, that's what National Science Foundation is always looking at it is because they don't want just theoretical research. The theoretical research is very important to develop the foundational ideas, but how can you translate that to a real system so that people can see and use for traditional, whatever the, persistent application into that. Okay, so so there are a lot of these things are there. So if you want to sort of contact me, there's a proposal also you can see because the ideas, what I presented is basically some of the new ideas, plus some of the old ideas, how, for example, the feature learning, feature extraction, and then, of course, the other important ideas of, the learning, what we call as a one-type learning, retransfer learning methods, and some of the important Markov models that we can use for establishing the pattern and so on. So there is a balance of both the theory, practice, and what is that we expect. So the expectation of this is developing real model with the technology transfer. So that's very, very important because every dollar the Congress spends on any of the research, they always would like to see what has been done to develop a technology. I was very fortunate because two of my research ideas have been translated and it was published on the National Science Foundation cover page, which is being used by Congress to say these are the two projects that have been selected because of the technology involvement and the final application. So thank you, and there are more things, I'll be very happy to answer any questions. Also learn if there are any methods that you are working so that I can also learn from that. Thank you. So, as I said, I think here in this institution has a lot of outstanding people focused on many aspects of quantum computing and integration of threat management. And there are lots of these ideas that we've heard about it, but I'm going to be sort of reading again some of these, researchers, learn from them and see what we can come up and define. What my real desire is to create a center of excellence here and as a real model that the whole world is going to appreciate what goes on in the SETS organization. Thank you. Any questions anybody has? So we'll be meeting some of these individual investigators, we'll be talking, and then we'll be doing it. Yes. Oh yeah, you have.
So you were saying about meta learning. So could you throw some more light on it? What is this meta learning?
The meta learning, basically what happens is, let's assume I'm taking a lot of image data. Now, the image data, so when they let's take a picture of mine. Now, a lot of times, the picture can be very fake. So there is what they call as meta image they want. So it is basically a skeleton image. I mean, it does not sort of give, the details of an image, but it certainly gives you certain amount of data that you can use, especially for many of the techniques like face recognition and things like that. What they really need in terms of the face recognition is they need the face, and the way in which they characterize the face is actually, they do have a lot of triangles to define the structure of the face. It is not something that what we see. So the structure of that kind of an image, the meta image is normally being used as a data that can be used for, getting the core values or the quality of the data. But they take more amount of data and they classify it. So metadata is always very important as being the core value the data that we are looking at. Yeah.
So you say the meta learning is actually incorporated in CNN model.
Yes.
So how the learning time will be? Because in CNN, definitely it will take some more time.
Yes. So very good question, because what happens is, since we are talking about three things: one, dynamic, right? And then we want the dynamic response in real time. And then we are talking about the meta learning. So that's why in the convolutional neural network model, we only use the data that is needed. I mean, although there is a voluminous data that you have, so we do what we call the feature extraction. So that means your data is already very much a data that you can use it instantaneously. So the learning time is fairly far less than taking a large amount of image. So I'm interested only in trying to learn as fast as possible because I'm trying to sort of, act on this dynamic text. So the data is already being clustered and it is being sort of, filtered fairly very good with some of these algorithms, the feature extraction algorithm, and that is very fast. It's all done on some kind of a real time. So by the time it comes to the learning, it's just kind of our human brain. I can simply say, no, I know that gentleman I met. I may not know his name, but I know his face, but I can say he's so and so. So that kind of, thing, but it is being done. But when you have data and when you have very high powerful algorithms that can be done in a factor of maybe a minute or two, that should be good enough for many of these. Yeah. Thank you.
This is in the context of this social media based data learning and things like that. Just want to know how would the learning algorithm take care of misleading information or biases?
Good. Remember, I think I told you the learning algorithm, by the time it has its input for the learning, still it has some what we call as outliers, and but not in very large numbers because all of those things have been filtered during the first and the second phase. This is at the end of the second phase. So you do have a certain amount of still, data which may not be very relevant. Now, in that particular case, it is going to do a guess. Guess in the sense, it takes what we call the consensus, like Byzantine, agreement. Like if you have 100 sensors and 80 sensors are good, 20 sensors are not good, then what we do, we look at the precision and the accuracy, and the remaining we call it as faulty sensor, and that we sort of leave it. So because the consensus is what it is, So when the consensus it says, like this is what it is, this is the right data. So it has proved to be 95%, Bayesian algorithm that we have used. It works very, very well. And so that's why precision, accuracy, and then the consensual aspect of all of the data items. So there are certain data items, even though it looks good, but it may not be good, but it would not affect the overall decision making. So the real-time decision making is what is important in many of these things. Right?
Just one small question. Sir, few shot learning.
Yeah,
Can you give us kind of a typical
example.
example?
Yeah, few shots learning. Okay, so the few shot learning is an important learning for two reasons. One is when we see the data and the features that we have already been extracted very well that we can make out, then we do not really need a very extensive learning methodism. So we can, have maybe one or two times we run through the algorithm, and if it is fairly consistent, then we move on. So that means all of these learning frameworks we have, we run that algorithm quite a few times just to get a very consistent value in real time. But if the data is fairly accurate, like 90-95%, the few shot learning is essentially very minimal that we need. That means we don't need to go beyond maybe 2 or 3 times. So the whole idea, remember this, is a real-time decision-making process, because that is very critical for many of these threat applications, because we don't have a whole lot of time. So we only have maybe a few minutes to make decisions. And these are the kinds of things that's used. Thank you.
Thank you, sir. There is a question online from
Yeah.
Mr. Joshua. He says that will certificate in ethical hacking suffice to get into cybersecurity program? What are the requirements to move forward in this field along with data analysis?
One more time, can you?
Okay, looks like this is a question related to training and getting skill enhanced probably.
Yeah.
He is asking, will a certificate in ethical hacking be sufficient? Or what are the requirements to move forward in this field, cybersecurity, along with data analysis?
Okay, so, well, of course, if you're a computer scientist already, but I would still, just a certificate may not be very sufficient, in my opinion. So don't make me wrong. But I think a little bit of an experience in developing a system and, seeing that you see to yourself, you understand the quality of the decisions that you can make and, during the whole process. So I think the good way is to have many of these workshops. And, in these workshops, we want to give students or anybody a good project. And I think this, within 1 or 2, maybe projects, they'll be able to get a good experience and implement the same kind of process.
I think
There's one more, John.
You were saying about this few shot learning, and if we are using few shot learning, and if my data set is class imbalance, so how can I apply it to real world cyber physical system? Wouldn't it be risky, the decisions that I make based on this model?
No, the few shot learning is a major part of the learning process. Okay, I mean, in the sense, if it needs fairly a detailed learning, yes. Because, see that you need when there is a large amount of data which is very noisy. And then you are able to sort of retrieve it and then you are collecting. Because the most important thing is if your feature extraction method, if you are not being able to extract some real good features which can help you to make real-time decisions, that can also happen sometimes. You may not have a very clarity on that. So in that case, when you have a very clarity on the data on the feature extraction, then the few shot learning is good. But if not, then you have to integrate with other aspects of the cyber security and see you are able to get something which is very unique for making intelligent decisions. So it depends on the first step and the data. If you have reasonably a good data, and I think if you can sort of do some of the basic things what I said, then you are good, which you can make decisions. Because there are sometimes the problem that you are talking is for medical applications. Because a lot of times the doctor has looked at all of these data and then he says this person has cancer. And then later on, by looking into some other additional data, because in some of those images, when they look at the data, they're not very clear. So that's why they say they want a second opinion, so that you want to augment your decision-making process with more reliable data in a way that your final inference is good. So that takes a little more time. If it is very crystal clear, the decision is fast. But if it is not, then you have to run through that.
How do you see the shift in the detection of threats in the era of quantum computing? So how AI can be used in quantum? There are two ways for that. One is using the quantum resources for making the learning faster, and the development of new algorithms in quantum itself. So QML kind of a thing, quantum machine learning,
Okay, so
and how it will be helpful for
So the idea, okay, so let's go back to the first question. Like, why do we use quantum computing, tell me? Because the data is very huge. And with the traditional computing, I'm not able to, I mean, it takes more time because I'm looking at, so we are looking for quantum computing or a quantum simulator. So the idea here is when you have a quantum computing good algorithm, efficient algorithm, then how good is your encryption algorithm? Because that's where you map correspondingly. Your encryption algorithm is fairly good. You get something like 90% efficiency to run and see that. So the algorithms, so it depends on two factors. When you have large amount of data where you're not able to use a traditional computer, then I want to use some quantum simulation to see how best I can come up with some results immediately as early as possible. So the question is, what kind of algorithm? So that's for that you have to design fairly a good symmetrical quantum computing algorithm in such a way that you are able to execute every part of it, because quantum computing doesn't work by binary status. It has, entanglement and different status. So you got to sort of make sure the algorithm that you use are fairly efficient to reasonably get a good solution on that. And it is possible because there are a lot of algorithms that are available right now, and that can be used even on the quantum encryption also. Okay. Any other question? Okay, thank you very much.
One last. I'm just seeing one last question from Dr. M. Meenakshi.
Yeah.
Online, she says AI can sometimes give highly biased result depending on the biases in the collected data set. Whether this approach can be robust around these biases. I mean,
Yes, very, very good point. As I said right in the beginning, one of the major factors in anticipating and predicting any of the threats is to minimize. I don't say that I will remove all the bias. It will never happen. There is certain amount. All that we can say is, I think our method can certainly give you a result which can minimize the traditional bias that you see now. And that's all I can say, because bias is always there. Right? Like for example, even our mind also, if you look at it, however good and even you're a saint, there are sometimes certain bias will always be there, right? So, but all that you minimize it. You don't need to make your decision just on that. So this method, what I presented, like feature extraction, learning, and then verifying, will certainly minimize the bias that we normally expect in many of the data sets or imbalanced data sets also. Okay. Thank you.
thank you. Thank you.